Okay, let's talk about types of numbers. The numbers that we study in 8th grade are numbers that can be classified as being rational or irrational. These are what we call real numbers, and we'll talk more about that down here in a second. But rational numbers are numbers that can be written as a ratio of two numbers. Basically, that means we are talking about fractions. And if something is a fraction, it means it does one of two things as a decimal. That means it either ends or terminates, like 0.25, or it repeats, meaning, again, you can find that pattern, like 0.3 repeating, 1/3, if you will. However, numbers that are irrational, by definition, it's the opposite of being rational, it's numbers that cannot be written as a ratio. And that means that they do not repeat and that they do not end. And we'll talk more about that in a second. So hit pause and write in your definitions. Let's talk about what it means to be the real number system. And so as you can see, the real number system is made up of two types of numbers, the rationals and the irrationals. And so let's start with the rationals, sort of nesting in the inside with these natural numbers. And natural numbers are the numbers that you learn to count by, meaning that you started counting 1, 2, 3, 4, and so on and so forth. So whatever it was that you were counting, you started with that. Those are also known as the counting numbers. Then you moved on to understanding what whole numbers were, meaning that you were going through and understanding that the whole numbers also added in the number 0. So as a child, you didn't understand that there was no cookies in front of you because you didn't understand that there was no cookies. So when cookies were put in front of you, you would start with 1, 2, 3, 4. You would eat them all. There you go. You understand the concept of 0 now. So that brings in the idea of being whole numbers. Now, integers, as you know, integers adds in basically negative numbers. So starting by, putting in whatever negative numbers you want, any negative number basically then is counted as that integer. So natural numbers are also whole numbers, and whole numbers are also integers. So basically, this portion of our graph so far makes up then basically the number line that would be like in my classroom. Now, rational numbers bring in something a little bit differently. Rational numbers, again, by definition, are numbers that can be written as a fraction. So you start talking about things that are either a numerator and denominator, maybe a number that would be like an improper fraction. But either way, if I can write something as a fraction, whether it's a terminating decimal or a repeating decimal, that means it would be a rational number. Then we talk about irrational. Irrational is basically everything else. Irrational includes things like pi, because if you remember, pi does not terminate, does not repeat. We approximate it to being 3.1415926, so on and so forth, but it doesn't end and there has not been found a repeating pattern within it. So it's classified to be as an irrational number. Same thing with something like the square root of 10. There is no number times itself that would give me 10. It's close to 3, but the square root of 9 is 3, which actually means that would be a natural number if we're talking about the positive version of that. So when we're talking about the rational versus irrational, mostly everything we do is going to be a rational number. Irrational numbers are the numbers that we do not know the answer to. And that is why we need to know and talk about our perfect squares and our perfect cubes. So at the bottom of your page there, you see our perfect square list, meaning that if I have the perfect square of 1, its square root is 1 or -1. If perfect square is 4, its square root is 2 or -2. I'm just going to list the positive versions right now. The perfect square of 9 would be 3, because 3 times 3 gives me 9, so on and so forth. So basically, if the number is not on this perfect square, it would be an irrational number. So let's take a moment and finish filling in your perfect square and your perfect cube list. I didn't list all of the perfect squares and perfect cubes in the world, obviously, but you can see that these numbers for your perfect squares go up to the number of 15, those are the ones you should be familiar with. So when you go through and you look at these and see a number like 144, that should ring a bell that the square root is 12. 196 being 14, so on and so forth. Same thing with your perfect cubes. You're probably familiar with 1, 2, and 3, understanding that 2 times 2 times 2 would give me 8, but knowing that 64 and 125 are on that list is pretty basic.